Hi guys, today we are starting with the topic of tail recursion. So before tail recursion, I would be giving you two problems and you would have to solve it along with me in a recursive way. So the first problem that we would be doing is that we have to print values from n to 1. That is, I have n natural I have given you an integer n and you have to print the values from n to 1. That is, suppose I am given 5, I have to print values in the order 5, 4, 3, 2, 1. Okay, so how exactly the recursive function would look like? So let the recursive function has a name fun. So it would have a parameter as n, and if the base case would be, so in this case, if I am going less than 1, there is no need of printing anything. So I would be just returning the call. So if n is less than 1, I would be just returning the call without printing anything. And if while n is greater than 1, that if the value of n is greater than 1, that is outside of the base case, I would have to print the value of n, and then I would be calling the second child recursive call, that is n minus 1. So I would be printing, that is system.out.println, and I would be printing see, I write the short form of system.out.println as s out. Okay, so it is system out basically, or print if you are unfamiliar with Java. So s out would be n, I would be printing the value of n, and I would be calling the child recursive call, that is fun n minus 1. So what happens exactly here is, first I am calling fun of 5, then I print the value of 5, then I am calling fun of 4, then I am printing the value of 4, then I am calling fun of 3, and so on. So I would be printing 5, 4, 3, 2, 1, and then when again the call is made, I would be going to the base case and I would be returning it directly. So this is how the recursive function would look like. Let me delete this particular section. Yeah, so this is how your recursive function would look like. So let's go to our idea console and let's code this particular thing and see what we are getting is our output here. So initially only I have taken a function as fun, and I have passed in a value of n, and I have called n is equal to 5 from my main function. Okay, so the condition would be, if the base condition would be, if n is less than 1, I would be returning the call, else I would be printing the value of n, and I would be returning the function call with n minus 1. So let me just run this particular program and see what we are getting as our output here. Yeah, so after completing its run, we have got the values as 5, 4, 3, 2, 1. So that was expected from us when we were asked to print the values from n to 1. So here I would have to print the values from, this was the program for printing, from n to 1. Okay, so now for the second program, that was, I have to print the values from 1 to n. So printing from 1 to n. Okay, so I would have to write a recursive function for printing the values from 1 to n. So it would still be similar. Void fun, I would have to pass an integer. So if I am giving an integer value as 5, I would be seeing the value that would be printed as 1 2 3 4 5. Okay, so I would be just calling the I would be passing the value as int n, and here also the base case would be if n is less than 1, I would have to return. Now I cannot print n here. If I am printing n here initially only, then I would be getting the reverse order that we had seen here. So first I would have to make my call to my child. So first it would be fun of 5, then fun of 4, then fun of 3. Till these calls I would not be printing anything. So let me just first reduce the values. Okay, let me just do from 3. Okay, so fun of 3 is done, then fun of 2 is called, then fun of 1 is called, then fun of 0 is called. Okay, so let me do this, that I would be first calling fun of n minus 1, and then let's just print the value of n minus 1. Let's just print the value of n. So it would be s out n. So this particular would directly return to my this function. So when it returns here, then I would be printing the value of n. So I would be printing the value of 1. Then I would be returning to my this particular function. So then it would be printing the value of 2, and then I would be returning to the call of this particular function, and it would be returning the value of 3, right? So I am getting the printing order as 1, then 2, then 3. So this is how your particular recursive function would look like if you are trying to print the values from 1 to n. Let me just remove this particular section also. Yeah. So this is how your function would look like if you are trying to print the values from 1 to n. So let me just go to our idea console and see how this particular program will execute. So it would be very similar to your previous program, only these two lines would interchange, right? These and this. So these two lines would interchange. Let me just check here. Yeah, so this would go above the printing statement, right? So let me just run our particular code. See, so after running this particular code, I am seeing that we are getting values from values as 1 2 3 4 5. So this is how your particular recursion function would work if you have to print the values from 1 to n. So let's now analyze both of these functions, recursive functions. So which of these do you think are faster or is faster? So I would first say you which one is faster. The function that we had written for printing the values from n to 1 was the faster function. Now you would ask me why this is the faster function. Why? This is because it implements something called tail recursion. So what is basically tail recursion? Tail recursion occurs when there is nothing else except the child call return, that is nothing after the child call return. So in a recursive function, you always call your same function again, right? So when you call your same function again, that is known as the child recursive call. So if we ensure that after your child recursion call there is no other operation occurring in your function, that is known as a tail recursion. So what would the definition be? The definition would be that the parent doesn't do anything after the child call returns. So after the value of n-1 has returned, there should be no other operations performed in your particular recursive function. So which particular function satisfies that? You can see when you are printing the values from n to 1 after your n-1 call, you are not performing any other operation here. But in case of your printing the values from 1 to n, after your function call, you are printing the values of n. So this is how on a black box level, you know that since the values from when we are printing the values from n to 1, you are writing a particular function that applies tail recursion, therefore it is faster. Now how it is exactly faster when we are using tail recursion? So let me remove this particular section of code. So how is it particularly possible that while you are implementing when you are implementing tail recursion, your particular program becomes faster? It becomes faster because something called tail call optimization. So let me write the term tail call optimization. So whenever your compiler sees a recursive function, it tries to implement something called tail call optimization. So if it is a tail recursion, it is able to do it very easily, and it is able to implement the tail call optimization, so your particular function operates in a much faster manner when you are applying the tail call optimization. So what exactly your compiler does when it is applying the tail call optimization? Let's see that. So I have my void fun and I have passed my value as int n, right? So what exactly your compiler does is it converts your particular recursive call into an iterative call. How does it do that? It does it with the help of a go to statement. So this would be the start of your program. This is just an identifier that implies that this position is the start of my program. Now if n is less than 1, I would be just returning the value. Otherwise I would be printing the value and I would be reducing the value of n by 1. So n is equal to n minus 1, and then I would be doing go to start. So what happens here exactly is, if your value of n is 5, so if your value of n is 5, so here n is 5, so it would not go inside this particular if condition. It would print 5 here, it would go to 4, then I would again go to start. 4 would get printed, I would go up, 3 would get printed, I would go up again, 2 would get printed, I would go up again, I would go to start, means I would go to start again, 2, 1. So all of these are satisfied for when you are printing the value of 1 in the next iteration, your value of n would be converted to 0. So when you are going to start again, that is satisfying your this particular condition, and you would be just returning the value, and thus you would be printing 5 4 3 2 1 in this particular sequence. So this is how your particular code is running faster in case of this since in case of tail recursion. This particular code is easier to run than in case of recursive in a particular recursion, because you have to maintain a stack in case of recursion. That is time consuming. Okay, each call has to be in a stack and you have to perform operations on them in that manner. Okay, so that takes much more time than this particular code to run. So this is how your tail recursion would occur in a much more faster manner than your normal recursion call. So you must always ensure that if there is a way you're writing your recursion such that you can implement it in a tail recursive manner, then you must always do so. Let me try to show you how to do it for a particular example. So we had learned how to do your printing the values from 1 to n in a recursive manner, right? So now I would be trying to implement it in a tail recursive manner. So this is in not a tail recursive manner because we are performing an operation after the child call, so it is not a tail recursion. So this is not a tail recursion, right? And we would be trying to implement a tail recursion, so we would be implementing tail recursion. So how would we do that? Let me once check that my recording is going on. Yeah, it's continuing. So how would we implement tail recursion here? So here, since we have only one parameter, that is n, and that is always decreasing, so it is not possible to go in an increasing manner in your tail recursion in your printing values without taking another parameter. So we would be taking in another parameter, suppose a is equal to 1, and we would be incrementing it with each recursive call. So let me show you what I'm exactly trying to say. So it would be void fun int n, and I would be taking another value as int a, and this would have an initial value of 1. Okay, means when you are doing the first call, it would have a value of 1. So if the rest of the conditions would remain same, if n is less, the base condition would remain same. If n is less than 1, I would be just returning. Now I have to go in an increasing manner. I have another value, that is a, which could keep in track of the increment, right? So I would be, let me just print the value of a. Initially it is 1, so it would print 1, and then I would be calling my function again, that is my child recursive call, and I would be passing in the value of n minus 1, since I have to reduce the value of n as I am going much deeper into the recursive calls, and I would have to increase my value of a by 1 so that I am ensured that in my next printing I am just printing the value of 2. So 1 plus 1 would obviously be 2. So in my next function I would be getting my value of a is equal to 2, and this would go on till n minus 1 times. So I would be getting a printing range from 1 to n. Let me show you how this particular code is working in a stack. So first I am calling fun of 3. Okay, fun of there would be two values, fun of 3 comma 1. I am printing the value of 1. I am calling fun of 2 comma 1, 2 comma so it would be 2 comma 2. Then I am printing the value of 2. Then I am calling the value of fun of 3 comma 1. Then I am printing the value of 3. Then I am calling the value of, I am calling the function fun of, so it would not be there has been a mistake, guys. So it would be fun of, it would be 2 minus 1, that is 1, and 2 plus 1, that is 3, and we would be printing the value of 3. And then I would be calling fun of 0 and 4, that is decrement by 1 and increment by 1 for A. Then this particular condition would satisfy, and I would be exiting my particular loop. So this is how your particular function would work when your when you apply tail recursion in case of printing the values from 1 to n. And now since you had seen how tail recursion works faster than the normal recursive implementation, so your code on the right hand side would be much faster than the code on your left hand side. So this is how you would have to implement tail recursion in case in order to improve your time complexity, or in order to improve your running time, in case you have to implement recursion in order to solve a particular problem. So let me just go to our idea console, and let's see whether we are getting the correct value or not. So I would have two variables here, int a, and I would be calling the recursive call. Let me just copy this, cut this particular value. So after you print the value of a, so here I would be printing the value of a, then you would be calling your function again with a value of n minus 1 and a value of a plus 1, and in your initial function call, as I had said before, you would have to pass a value of n and a value of a, and always the value of a would be initialized with 1. So I would be printing a value of 1. Since we have to print a value from 1 to 5, so it would do this particular so I would have to pass a value of a is equal to 1. If I would have to print a value of 0 to 5, I would be initializing it with 0, but in this case it is just 1, so I will initializing the value of a by 1. If I am running the particular code, so let's just wait for it to complete compilation and run this. So I am getting the output as it has completed its execution. So I am getting my output as 1 2 3 4 5, and it is in a much more faster manner because tail call optimization could be applied in this particular code rather than the previous one. So thanks for watching this video, guys. I hope so you understood the concept of tail recursion and you would try to implement it more and more in order to solve your recursive problems in a much more faster manner. See you in the next one.